Appendix A in almost any textbooks is called Fundamental Physics Constants, listing velocity of light, Planck's constant, electric charge, and so forth. And this is sold by obedient physicists as fundamental inputs required by incomplete, flawed physical theories. With multi-millions in research funding, the scientists appear very authoritative. However, the greatest body of unexplained observations in physics, think about that, the greatest body is the so-called fundamental constants. So Appendix A in your Physics 101 textbooks should say most important unexplained data in physics. News alert, Binary Mechanics Lab published first ever derivations of basic physical constants from first principles. Here are equations for the alpha coupling constant and the Bohr magneton, which express those values in terms of other so-called fundamental constants. The measured values of these so-called fundamental constants are not independent, as these equations show. They contain redundant information. If they didn't, you couldn't write these equations which you see right before your eyes now. Therefore, these constants are not fundamental, and furthermore, they could not be fundamental if you understand what a simple algebraic equation is in fact saying. We might use an analogy to a video game in our adventure to derive the primary and secondary physical constants. We start the game located here between the orange box and full quantization in the green box. This is our wasteland where for hundreds of years, even millennia, investigators have based their work on the assumption of continuous energy, space, and time. In recent centuries, the theory of continuous energy, space, and time included classical physics, special and general relativity, and outdated 20th century quantum mechanics. But this whole area of our game map has turned into sort of a wasteland where, for example, in the game Fallout 3, a weather report might be scattered mutilations with occasional dismemberment. So, what we need to do is to venture into the postulate of binary mechanics of full quantization of energy, space, and time. Now, we're going to have to dip into the unexplained measurements, wrongly called fundamental constants, to reverse engineer these secondary constants below to obtain primary constants above. Let's look at that. With the postulate of energy, space, time quantization, the next logical question is, what are the values for energy, length, and time? How do we determine the values for energy, space, or length, and time? Well, we're going to have to look at the measured values for the so-called fundamental constants shown in red boxes here in our physical constants derivation tree. We use certain guidelines to reverse engineer the unexplained measurements to discover the primary constant values. First, we use dimensional analysis. In the derivation tree, units of derived values must follow from the units of input values. For example, bit velocity has the units of length divided by time. Electron rest mass has the units of energy expressed in kilograms. Planck's constant, which comes from our elemental action A, contains an expression for energy, mass times velocity squared, and an expression for time, our primary time constant. In other words, the units for the Planck constant are joules second. Likewise, the units of elementary charge are energy length, or joules length. Second, we have theoretical constraints. Binary mechanics postulates imply specific limits and or constraints on possible values. An easy one is the speed of light. If you look at the spot cube model of space in binary mechanics, a unit of energy cannot just move in any arbitrary direction. It can only move out of that spot cube through the 6 faces of the cube. In other words, there's only 6 directions it can go. And so for a unit of energy to move from some arbitrary point to another arbitrary point, it has to take sort of a little bit of a zigzag pattern, usually, to get to the destination point. So that's a constraint. So therefore, we actually have that bit velocity is actually pi times the speed of light. Another theoretical constraint is that the spatial model of the spot cube lattice of space shows that the electron contains 3 M-type quanta. And so therefore, to be consistent, the energy constant here must be 1/3 of the rest mass of the electron. Another guideline is that calculated values must agree with unexplained observed measurements. For each of these items in the red boxes here, there are published, measured, observed values. Prior to binary mechanics, it was not understood why these quantities had the particular measured values that were observed. However, with those measured values, and if the quantities for energy, length, and time are correct, we should be able to calculate what the measured observed values are, and that should all agree. And all of this was set up in spreadsheets to calculate the values to confirm that these quantities for energy in kilograms, length in meters, and time in seconds, in fact, according to the equations shown here, give you the observed measured values. That is a critical point. Lastly, basic formulas in Physics 101 textbooks were applied where applicable. For example, to calculate angular momentum, it is the sum of the angular momentum of the various energy quanta, which I call one states, as they revolve around in what we call the bit cycles for the electron and the proton. So I think we're doing pretty good in our venture into the wonderful land of full quantization in binary mechanics. And our character hasn't had to use any health packs or stim packs because we haven't taken any damage. And so let's proceed. We've reversed engineered the secondary constants below and to obtain primary constants above. And then with those primary constants, we can calculate the unexplained observed values. Let's look at this quest in a little bit of detail. A series of papers document this second quest. We can do a quick walkthrough of the papers published in the Journal of Binary Mechanics, which establish that we can calculate from the primary constants of binary mechanics the measured observed values of the so-called fundamental constants, which I call secondary constants. First, we have zero electron electric dipole moment. Here is the electron quanta cycle, where the two types of energy, quanta, shown by circles and arrows, revolve around a central axis shown by the gray dot here, which is perpendicular to the page. There is no collection of charge on one side or the other, and so the what we call the electron electric dipole moment is zero. And this agrees with findings of major labs, which have thought that the shape of the electron therefore must be like a sphere. But in fact, in binary mechanics, it's more like a spinning top shape. Unlike the electron, the proton has a non-zero electric dipole moment. It's sort of like a water molecule, where one side of the water molecule is more positively charged than the other side. That's what we mean by an electric dipole moment. This finding also agrees with experimental results from major labs. The electric charge positions can be viewed in sort of an X-ray fashion, where the dark red is plus and the yellow is minus charge. And you can see from these two views that the plus charge is more to one side of the proton and the negative charge is to the other side. Here is a detailed analysis of the positions of quanta in the proton bit cycle, which was used in this analysis. Next, we have the fine structure constant derivation, where the fine structure constant was plotted versus quanta density, shown here. Alpha is simply the ratio of the scalar and vector bit operations, which involve electric for scalar and magnetic for vector, divided by the number of M-type quanta available to be accelerated by these two potentials, scalar and vector. That is the definition, very simple, in binary mechanics of the alpha coupling constant. Running the binary mechanics lab simulator, we find that the fine structure constant alpha varies somewhat when plotted against quanta density. The red arrow shows the accepted value of about 0.00729. Intrinsic proton spin derivation. This is one of several papers that derived the measured value of Planck's constant h from analysis of quanta spinning in the proton bit cycle. Here is the proton bit cycle showing that it contains 42 locations and that quanta move around this circular area here in the proton bit cycle and have an intrinsic angular momentum. Light speed derivation. We can fire one state quanta into a simulation using the binary mechanics lab simulator and measure the speed of light by noting the arrival time of these quanta to the other side of the simulation. If we have a cubic volume that we're simulating and we shoot quanta in for a light signal on one side, we can see how many ticks of the binary mechanics lab simulator are required before these quanta arrive at the other side. That's what this unidirectional light speed measurement data is showing. Here are the details of how all of that was calculated. The calculated light speed, of course, is bit velocity v divided by pi, so that we can express light velocity in bit velocity units of 1 over pi. In those units, light front velocity was approximately 0.319, or within about 0.3% of 1 divided by pi in bit velocity units. This is a remarkable result. Elementary charge derivation. We can take a look at what happens with the electrostatic force in the scalar bit operation. If two like-signed charge, these are the M-type quanta shown by circles, if one moves this distance, the separation then is the hypotenuse, and we can calculate what the electrostatic force actually is, and therefore determine, using Coulomb's equation, what the value of the elementary electric charge is. Intrinsic electron magnetic moment derivation. Our calculations give you the measured value in joules divided by Tesla units for the Bohr magneton. So finally, unexplained measurements are now all accounted for. We've done a great job. We have beat the big boss in the game of deriving primary and secondary constants. The basic result is that the primary constants of binary mechanics, shown in the green full quantization area here of our open world, have won the game of physics. Have a great day, you all.